Hallo. Ja.
Welkom allemaal. Wij gaan jullie vandaag ons nieuw concept Experience Twin voorstellen. Het concept is ook gelinkt aan een nieuw project en ook een nieuwe samenwerking die we vanuit onze onderzoeksgroep van Universiteit Gent samen hebben opgestart met de onderzoeksgroep HitLab van HoWest. Dus de bedoeling is eigenlijk nieuwe technologie. Oh, dat is Nederlands. Hè? Iemand die Engels praat? Okay, I'll switch to English, sorry. The goal is to use new XR technology to make user testing much more cheaper, faster, and more objective. We think this new technology and the framework we'll present to you will help in product design, user experience testing, training and assessment, and also can be used for market research and also to increase your sales. But firstly, let me introduce our research group. So, as I told you, we're two research groups. One research group is from Ghent University. It's a very interdisciplinary research group where we combine different expertise and focus on user experience. So, we look at how we can interact with people and define new interfaces and the experience design around it. We're also an IMEC research group, so we, of course, link and use much of the new technology that is being developed there. We have three ways to interact with humans. So we focus on what people say using questionnaires. We look at what people do. We look at observational studies looking at their behavior, but we also focus much more on also their digital behavior, which also is very handy when we look at XR technology, because using XR technology we can digitize more and more the human behavior, and we focus also much more on what people feel and what people think using physiological sensors in order to get a very good user model and to understand what humans want. The other group, and I give the word to Jelle.
To the other Jelle, so both Jelles. So in HoWest we have a multidisciplinary team of game developers, AI engineers and psychologists. And we also focus on human interface technology, which is to us is a combination of measuring humans, so digitizing human behavior, understanding that with intelligent algorithms, and to link back those information, if possible, with the newer XR interfaces. So indeed, as a lab, we are very complementary to the research lab of the other Jelle and Klaas. In that they are more linked to the university, so closer linked to more scientific findings. We as HoWest, so a more applied university, are very close to the field and really try to test if those applications can make a difference on the floor, also in the factories and in society.
Okay. Thank you. So, as I told you, we joined forces, and the goal is to focus on new technologies. One of these new technologies, we call this Experience DNA. And the movie works. So, Experience DNA is actually a framework in which we aim to understand much better how humans can interact with future technologies. Here in the movie, you see our lab in Ghent. And the concept is based on a future where we will interact much more with smart environments, with smart products. And in this shift of technologies, it will be much more important to understand the human experience and how the human will interact with these new technologies. Here you see some examples. So. It can be home appliances, it can be industrial automation, but most of us already realize that you will be interacting much more with digital information. when we interact with these systems, we have a kind of experience, and we try to entangle this experience as strands of DNA. And of course, as designer or design team, you try to envision a very perfect experience, but this perfect experience doesn't always match with the actual experience that users have. So here you can see an example where we did first test with future cooking experiences, where a recipe is being presented via an automated tablet. But of course, during these cooking experiences, a lot of unforeseen actions may happen. Instead of doing a lot of expensive user testing in-house, we can build actually a digital twin of this experience. We make a copy of the environment, or we buy assets online that can represent the environment and everything that you would need. And when we have this digital copy, we can place users inside this digital environment, and we also track what these users see, their eye gaze. We can track their pupil dilatation, we can track their facial expressions, we can track their motions. And when we combine all these physiological measurements that we synchronize digitally in our framework, we actually have a very good model to know what are all the interactions that these humans have. And we can use this in a lot of future applications. And what is the main advantage is that this is how you see we do the user testing today. So in a future cooking experience, we build 1 or 2 very expensive prototypes based on interviews that we do with potential users. But the problem is that, we need real physical spaces, real objects, real people. This is expensive, very time-consuming. Also, if we gather data input from this user, we need to do this manually. So our researchers observe, maybe using cameras, but they need to take notes. We need to take data measurement from the sensor, and post hoc, we need to synchronize all this information to make sense of all this data and to determine where the user experience is good or where the user experience is bad. If we switch to a fully digital user experience and user experience testing, we have a lot of advantages because everything is virtually present. It's very cheap. We can adapt it, we can copy it, we can share it. Also, within our framework, we build an automatic tagging system, so all the data is synchronized. We can directly start looking for patterns, directly detect wanted or unwanted behavior, and this gives us a lot of advantages. So we build our first prototype now, but the aim in the future is that we can simulate almost any possible interaction, and that we also capture all the interactions that a user does in this digital environment. So here you can see the technical framework, where we use, from the one side, different types of sensor. We use Unity, a well-known 3D engine, to do the VR rendering. And then we use also open source and different kind of building blocks for the data acquisition and the data representation in an online platform. So we can build different kind of dashboards, for example, to monitor ergonomics during specific experiences. Also, for example, to control what happens in the environment when you are in a learning VR scenario. And if you combine all this, you get a very flexible framework. And again, a good combination of a very highly immersive, realistic feeling in the VR experience, but at the same time, a very controllable, trackable lab context in order to get really quantitative and qualitative data, so we can have scientific insights on what is happening. Of course, one of the disadvantages still in virtual reality is the tangibility, but also there we are exploring with our students the possibilities of combining virtual reality, for example, with quick and dirty prototyping. If you 3D print, if you prototype something, it can be very fast, but most of the time we also call it quick and ugly prototyping sometimes. But in combination with VR, here you can see in the movie, we create interactive prototypes that really look well and that you can actually touch, that you can actually grab. So for us, virtual reality is a really essential or a very promising technology within the design process. And it actually combines the downside of the rapid prototyping with the opportunities with the virtual animations and renderings. And of course, we create flexible solutions in order to make your rapid prototypes experienceable, interactive in a VR environment. And then I give the word to Klaas.
Yes, so to follow up on this, as we said, I think this is an audience that is mainly interested in design, engineering, prototyping. We wanted to build a tool in which we can create experiences where people can experience technology that doesn't exist yet. But if the technology doesn't exist yet, of course, it should be possible to elicit behavior or to create events that cannot be realized in real life. So our framework also includes like a wizard tool, which is basically a dashboard for the designer or the engineer or the researcher to make things happen in the experience. For example, in this cooking experience, the scene control buttons allow you to make, for example, to heat the stove automatically based on the step in the recipe, or to put the kitchen hood on whenever a certain temperature is reached. So all these kind of non-existing IoT applications can be tested out first in this environment. And then also data collection is very important, so we can collect the data on the IoT devices or the prototypes itself, but we can also collect data on the user working with the technology. And there, virtual reality is an interesting solution because it has already built-in sensors. So for example, the HTC Vive, which is a very often used HMD, so head-mounted display for virtual reality, has very good built-in eye tracking. So it's made by Tobii, and they're a very good manufacturer of eye tracking. So this allows you to do eye tracking research in very great detail and know exactly where people are looking at what point in the interaction. So besides this behavioral analysis, you can also look at psychophysiological reactions. So when people are aroused or confused or hesitating, sometimes the body responds as well, and that's not controllable, so you cannot lie about it. And with the use of, for example, pupil dilation or a heart rate sensor, we can also detect those events. Now we will show some examples of where we use these platforms in projects. For example, this was a project in which we looked at on how to set up a control room for surveillance applications. So if the video, no, the video didn't play. Yeah, no, it won't play. But as you can see on the screenshot, people are in a virtual control room. And of course, the big advantage is if you want to prototype or test out new configurations, you don't have to hire an existing control room, or you don't have to build a physical one. You can just rearrange the screens in whatever configuration you want. You can try out AI algorithms if you want for automatic detection of events or movements, and you can see how an operator reacts to it. And what we will typically do is also include like additional tasks for the operator. For example, picking up the phone, calling numbers. So the cognitive load is increased, and we know this operator is in a state of cognitive load, and then we can see how he reacts to certain technologies or AI assistance mechanisms. Another example is a project in which we look at the collaboration between a human operator and a cobot. So this person on the right, but this probably also won't work. Yeah, he has to assemble an object in close collaboration with a cobot. And here as well, we can see how he reacts to certain actions of the cobot. And whenever, for example, cognitive load is detected, we can change the behavior of the cobot. And doing so, we can actually come up with new ways a cobot can interact with a human operator that we didn't know before. And of course, it's much safer than working with a real cobot in a research phase. Another project is on the design in like smart spaces or smart city environments. We can prototype new ways of people interacting with the heritage of a city. So this was, for example, an experiment we did for the city of Ghent, in which people could explore like an ancient visualization of a certain area in Ghent. And finally, a final example is we also use our Experience DNA platform for training and assessment. So for example, in this example, we made an entire training for nurses to train communication skills in virtual reality. Again, nowadays this is done by role-playing, and of course very costly, very time demanding. People have to make annotations, people have to give feedback in real time, but they don't see all the small things happening, and this platform allows us to actually at the end print a report with a timeline and all the critical events aligned. And now my colleague Jelle will talk about a project we did together with the people from HitLab West.
Yeah, of course, if you're putting people in a virtual environment and you're measuring their reactions, you take the assumption that everybody reacts in the same way on stress, on cognitive load, on concentration, for example. But that's not true. People react in different ways. Trying to make a general model that can interpret the mental state of a person while doing a virtual training, it's difficult. And that's something we wanted to tackle in Calibrain. In Calibrain, we've put people in certain situations with a high cognitive load, a high working memory load, high concentration, high spatial cognition tasks. And we will look at the individual level how people are reacting. And we are creating a calibration file for that person so that afterwards, in another task, you can more easily interpret the raw physiological measures of that person. Yeah? So that's Calibrain, so that's part of the bigger story, of course, that's focusing on one specific problem that we have, namely the interpretation of these physiological measurements. And to do that, we have created a virtual futuristic factory where people are doing tasks, fun tasks, but in fact they are boring experimental scientific tasks, but people don't know that. So it's a paradigm that we transformed, that they can do it in a fun way, and so we can. That's what I talked before. So why is it important that we can estimate if a person has a high or low cognitive load, and how he reacts to that? Well, because in the end, if you want to make virtual trainings that are adaptive and are personalized to the person that is doing it, you need to estimate what the person is feeling, what he is thinking, and the software should adapt to that person. So that's the idea behind it. So the training itself, so it's a VR experience of about 20 minutes. It's strange that it switches. People have to do some tasks. We make a calibration file for each person, and this calibration file can then be used in other VR trainings to translate the raw physiological measures to the developer or the data scientists that then can easily interpret those signals. It consists of different components and different tasks at this moment. We have a lobby room, which we use as a baseline measurement of the people. We have a cognitive load task, which is in fact a kind of a memory task while you are putting boxes away. We have a spatial awareness tasks where people have to estimate if a certain shape is the same as another shape that they see, but it's rotated, so that it's a mental rotation task. Performance on that task gives a good estimation of your spatial capabilities. So this is, if you want to have more information about this, we can maybe even send you a build that you can test it yourself. The idea also of Calibrain is that if you're interested in that, companies indeed can integrate this application with an API in their own software, and so that it will ease the interpretation of physiological measurements, but it's still backed up with scientific knowledge. Okay. All right.
Okay. Thank you, Jelle. And I think, yeah, this sums all our experiments a bit up. Of course, all these experiments, they contribute to our general knowledge on trying to build this kind of digital twin of interactive experiences. We focused a lot now on the framework and looking at the output, where we use sensors on the users, but also take a lot of the digital information that is available if you start doing interactions in VR. So we have the log data and the interaction data. But also together with you, with the companies, we would like to explore a bit more what do you need from the output data, but also what would you need from input data. Sometimes you say, I just need, let's say, a manufacturing environment, a factory, but sometimes it has to be a very specific factory. It has to be your factory. The same with object data. Maybe it can be any kind of mixer or any kind of cooking plate, or it has to be your new product. And there we want to see now together how we get and make this process very easy, get your input into the framework and also deliver the output that is necessary to convince your customers or to improve your products. And that is why we're a bit happy to say that we got funding of the Vlaio Tetra project, where we want to focus more on the input and the output, looking at which kind of CAD models, which kind of other types of input data are relevant for you, your products, your customers. And also on the output side, which kind of reports, which kind of, is it stress data from the user, or is it performance data from a scenario, or training or learning data for assessment that is relevant for you. Let us know, and we can collaborate in this Tetra project, and we are now open for new partners. We'll start the project the 1st of October, but the cases will start around January next year, so we still have a few months for companies that are interested in that. And maybe, the type of memberships you can discuss with us later. And then this vision is also supported by XR Valley, which is also a new initiative that we as co-member started. But I will give the word again to Jelle, who started this initiative.
Yeah, so XR Valley is a new network organization grouping all the stakeholders in XR industry. Also, not only the technological side, so the XR developers and the game studios, but also the end users, so the companies that want to experiment and want to integrate XR technology in their own company. We have different verticals. That's important for today, is that we have a design and engineering vertical. It's a committee, it's represented in a committee where new initiatives are formulated in the design and engineering sector. So you're kindly invited to visit our website to see if it's interesting for you. And on the right, you can see that we have a Discord channel that you can already participate in the discussions online and see if it makes sense to become a member or to join other events that we are organizing.
I think even after a few months, it has already become a very vibrant community. And this is then also a call for all of you, if you are interested to interact with this, to become part of this community. Looking at what XR has to offer, we have a lot of possibilities, from just giving you some information to actively work together on future use cases for your product. So thank you all for listening, and if there are any questions, please talk to us.
Thank you.